So imagine an employee leaves your company. HR processes the departure, right?
Yeah, standard offboarding.
Exactly. They hand in their laptop, their central profile is instantly deactivated, and, it feels totally secure.
Right, on the surface.
But beneath the surface, for like the next 5 years, a shadow copy of that employee's personal data just sits silently in your cloud architecture.
Just multiplying.
Yeah, multiplying across dozens of sub-accounts, totally disconnected from your HR system, and just sitting there, silently violating GDPR and data privacy laws every single day.
And no one even notices.
Exactly. And today, we're going to show you exactly how to stop that from happening.
Because it is, frankly, one of the most common and probably most dangerous architectural blind spots we see.
Yeah, 100%.
I mean, we always think of identity as this single centralized truth, but when you step into the world of enterprise-grade cloud architecture, and specifically, the SAP Business Technology Platform identity is incredibly fragmented.
It's all over the place.
It really is. And the default settings that SAP provides, they're designed to get you up and running quickly for a trial, right?
Right.
But if you rely on them for production, you are just, you're walking straight into a compliance and scalability nightmare.
Which is exactly why you're with us for this deep dive today.
Sure.
We are completely bypassing the generic high-level marketing fluff here.
No fluff today.
None. If you're listening to this, you're likely an architect or a security lead, maybe a developer, and you need to master the actual under-the-hood mechanics of identity and access management, or IAM on SAP BTP.
The nuts and bolts.
Exactly. We aren't just going to, talk about the theory. We're going to break down the specific configuration steps, the traps you need to avoid, and the actual hands-on moves you have to make to secure a complex SAP environment.
Because you really have to deconstruct the entire journey of an identity.
Right, from start to finish.
Yeah. We'll start at the origin, where a user record is actually born, and then trace how it flows through these central SAP Cloud Identity Services.
And then follow it all the way down into the runtimes.
Exactly, because how you secure a traditional ABA environment is vastly different from how you handle, say, a Kubernetes-based Kyma environment or a Cloud Foundry space.
Well, let's start at the perimeter, right?
Yeah.
Because before anyone can even touch a database or deploy an application in BTP, someone or some system has to authenticate them.
They have to get past the bouncer.
Yeah, past the bouncer at the door, yeah. And in the SAP universe, this is handled by a suite called SAP Cloud Identity Services.
Right.
But here's the trap, right? The trap we see everyone fall into. When you first spin up an SAP BTP global account, there's already a default bouncer at the door.
The SAP ID service.
The SAP ID service, yeah.
And, the SAP ID service is entirely managed by SAP. It's the exact same identity provider you use when you log into tools like SAP for me or the SAP support portal.
Using S users and P users.
Right, exactly.
Let's actually pause and define that really quickly for anyone who might be new to the ecosystem. So an S user is an SAP support user identifier, usually tied to a specific customer or partner number, right?
Yeah, that's right.
And a P user is a public user, like anyone who just signs up for a free SAP community account.
Precisely. And because those user profiles belong to SAP's central database, the SAP ID service is just, configured as the default trust in every single new BTP sub-account.
So it lets you immediately log in and start clicking around.
Exactly. It's frictionless for a trial.
But literally every piece of architecture documentation basically screams at you to abandon this default setup immediately if you're building anything for production.
Yeah, it's a massive red flag.
And you're actually entitled to at least 2 custom tenants of SAP Cloud Identity Services anyway, like one for testing, one for production. So let me push back on this a bit.
Go for it.
If the default works out of the box, why are we ripping it out? I mean, if it requires setting up a whole custom tenant and mapping out corporate groups and configuring OpenID Connect trusts, why not just use the default for a small internal project?
Well, it comes back to the exact scenario you painted at the very beginning of this deep dive.
The GDPR nightmare.
Yes, the lifecycle issue. In enterprise security, identity originates in your human resources system. Maybe that's Workday or SAP SuccessFactors.
Right, the actual source of truth.
Exactly. When someone is hired, promoted, terminated, HR is the source of truth. If you use the default SAP ID service, you don't own that identity provider. SAP does.
Right.
Therefore, you cannot connect it to your HR system. When an employee is terminated, you have absolutely zero programmatic way to automatically revoke their BTP access.
Okay, that makes total sense. If you don't own the engine, you can't connect it to your own bricks.
That's a great way to put it, but honestly, it gets
Oh,
worse.
great.
Yeah, even if we completely ignore the lifecycle issue for a second, the default SAP ID service just lacks the fundamental features you need for modern enterprise security.
Like what?
Well, you can't configure custom password policies. You can't enforce your company's specific multi-factor authentication rules.
Wow. Yeah.
And critically, you cannot assign authorizations based on user groups. It literally forces administrators to assign BTP authorizations user by user completely manually.
Which is a scalability nightmare. I mean, if you have 5 developers, fine. If you have 500 developers, you're hiring an army of administrators just to sit there and click checkboxes all day.
Yeah, exactly. So the architectural mandate is just super clear. You must pivot to your custom SAP Cloud Identity Services tenant.
Well, let's unpack what that custom tenant actually is, because SAP Cloud Identity Services, it isn't just one monolithic tool, right?
Sure.
It's a suite made up of 4 very distinct pillars.
Right.
I want to break down how they interact natively, because this is where the actual mechanics get incredibly interesting.
Let's do it. So the first pillar is identity authentication.
Okay.
This is the component that actually intercepts the login request. It handles single sign-on. It evaluates risk-based authentication rules.
Like prompting for MFA if the user is logging in from an unknown IP address.
Exactly. And it acts as a proxy to your corporate identity provider, like, say, Microsoft Entra ID.
Got it. So identity authentication is kind of like the interrogation room. It
Right.
checks the ID, it checks the risk, and it issues the pass. What's the second pillar?
The second pillar is identity provisioning. We're going to talk about this extensively when we get to the shadow users stuff, but fundamentally, this is your automation engine.
Okay.
It uses a protocol called SEIM to automatically push and pull user records across different systems.
SCIM sits in for cross-domain identity management. Yep. For those who haven't worked with it, it's essentially the universal API standard that allows completely different systems to securely pass identity data back and forth.
Yeah.
Usually using standard JSON structures.
Right.
It's how an HR system tells a cloud platform, hey, this person changed departments, update their profile.
That's a perfect definition, yeah. So we have authentication handling the login and provisioning handling the lifecycle flow.
Makes sense.
The third pillar is the identity directory. This is the persistent database. It is the absolute centralized point of truth for users and groups across all your SAP cloud solutions.
Okay, and I think this brings us to the fourth pillar, which, frankly, I find to be the most fascinating shift in SAP's recent architecture, the Authorization Management Service, or AMS.
Oh, yeah. AMS is a game changer.
Right, because for the longest time, anyone working in BTP relied heavily on XSUAA, the traditional authorization and trust management service, to handle permissions locally in the BTP cockpit.
Yeah, XSUAA was everywhere.
So what is the mechanical shift to AMS actually all about?
Well, XSUAA is very binary, right? You either have the manager role or you don't.
Black and white.
Right. But AMS represents a massive strategic shift toward centralized, policy-based access control. What makes AMS so powerful is its ability to handle instance-based authorizations, or what SAP calls restriction.
Let's make that concrete for the listener.
Yeah.
Under the old XSUAA model, I might give a user a role collection that allows them to, say, view sales orders.
Yep.
But they see all sales orders globally, right? To restrict them, I have to build incredibly complex logic into the application itself. So how does AMS handle that differently?
With AMS, the authorization logic is decoupled from the application entirely, and it's centralized up in the identity directory.
Oh, interesting.
Yeah. So an application developer writes a base policy just saying, hey, this app requires a permission to view sales orders.
Okay.
But the administrator uses AMS to create an admin policy that attaches restriction to it. They can say, this specific user group can view sales orders, but only where the region equals Europe.
Wait. If AMS is centralized up in the identity directory, doesn't that create a massive latency issue?
How do you mean?
Well, if an application running down in a BTP sub-account has to ping the central identity directory every single time a user clicks a button to see if they had that Europe restriction, I mean, that sounds like a huge bottleneck.
Ah, I see what you mean. But that's where the underlying protocols come into play. It doesn't ping the directory for every single click.
It doesn't.
No. When the user authenticates, the Identity Authentication Service issues an OIDC OpenID Connect token.
Okay, the OIDC token.
Right. This token is essentially a cryptographically signed JSON payload. AMS injects those specific restrictions directly into the token's claims.
Ah, So the token itself carries the permissions.
Precisely.
Hmm.
The application router in BTP simply decodes the token. It verifies the cryptographic signature to ensure, it hasn't been tampered with.
Right, right.
And it reads the restriction right there in memory. It's incredibly fast.
That's brilliant.
It is. But, and here is the crucial architectural constraint you have to remember. For AMS to inject those policies, the user profile must exist centrally within the identity directory. You cannot just map them on the fly.
Which brings us to the very practical application of this.
Mm,
For the listener who is building this out tomorrow, your first move shouldn't be writing code or spinning up databases, right?
Definitely not.
Your absolute first priority, your first action item, is logging into the BTP cockpit and claiming your custom SAP Cloud Identity Services tenants. You need to get your test tenant and your production tenant physically connected to your global account.
Exactly. And once you claim them, you have to establish trust. And honestly, this is where we see a very common configuration error.
The OIDC trust issue.
Yes. You need to establish an OpenID Connect or OIDC trust between your BTP sub-account and your custom identity authentication tenant.
And the documentation is wildly emphatic about this, right? It says you should only establish one custom trust per sub-account.
Yes, exactly, one.
Because I see architects trying to create multiple trust configurations in a single sub-account all the time, like maybe one for internal employees and one for external partners. Why does doing that break the architecture?
Because of how the new centralized services, like AMS, actually resolve identities. If you have multiple custom identity providers configured in a single sub-account, the newer applications that rely on the central identity directory just get confused about which source of truth to pull the authorization policies from.
It fractures the token flow.
Exactly, it fractures it. You set up exactly one custom trust via OIDC. If you need to support external partners, you handle that routing up in the identity authentication tenant, not down in the BTP sub-account.
Okay, that is a huge takeaway.
Yeah.
So we've established our perimeter, we have our custom bouncer at the door, and they are issuing these tokens carrying detailed restrictions.
Right.
But now we really need to talk about who is actually walking through that door. Because SAP BTP enforces a strict fundamental split between two types of users.
And if you don't understand the split, your security posture is completely compromised.
Literally compromised.
Yeah.
We are talking about platform users versus business users. BTP treats the builders of the system fundamentally differently from the consumers of the system.
It's night and day.
So let's define that boundary for the listener. A platform user is your architect, right?
Yeah.
Your developer, your system administrator.
Yep.
They're the people who log into the actual BTP cockpit UI, or they use the BTP command line interface to entitle services, manage account quotas, and deploy application code.
Yes. Conversely, a business user is the end user. They are the financial controller logging into a custom application you built to approve an expense report.
Right. They're just consuming the software.
Exactly. They never log into the BTP cockpit. Honestly, they probably don't even know what BTP is.
To use a physical architecture analogy, the platform users are the engineers and security teams who hold the blueprints to the bank vault.
I like that.
Right. They can change the locks, they can expand the vault, they can delete the security footage.
Terrifying, but yes.
But the business users are the bank tellers and the managers. They can open specific safety deposit boxes inside the vault to do their jobs, but they cannot alter the vault itself.
Right.
So why does SAP mandate such a hard line between these two personas at the architectural level?
Well, it's primarily to enforce distinct authentication strengths without degrading the user experience.
Okay.
Your engineers, the platform users, they have the keys to the kingdom.
Right.
If a malicious actor compromises a platform user's credentials, they could delete production databases or, spin up crypto mining environments that cost you millions of dollars over the weekend.
Or alter the IAM policies themselves and lock you out.
Exactly. Because of that catastrophic blast radius, platform users require incredibly stringent authentication policies, like mandatory, unbypassable multi-factor authentication.
Right. But if you applied that same rigid, high-friction authentication policy to the bank teller, the business user who just needs to quickly click approve on a timesheet, the business would just grind to a halt.
People would rebel. Business users might only require a standard single sign-on check against their Windows domain login, or perhaps just a biometric check on their phone. By separating the personas, you can route platform users to a highly restrictive authentication policy in your identity authentication tenant and route business users to a more seamless policy.
That makes perfect sense from a security posture standpoint. But in executing this, BTP relies heavily on a concept that brings us right back to that terrifying GDPR scenario we opened with.
The shadow users.
The shadow users. Let's unpack this concept. What mechanically happens in BTP when an admin assigns a role to a business user?
Okay, so when a sub-account administrator goes into the BTP cockpit and grants an authorization like a role collection to a user who belongs to a custom identity provider, BTP needs a local object to attach that authorization to.
It can't just attach it to thin air.
Right. So it automatically generates a local copy of that user's profile right there inside the sub-account. This is the shadow user.
And what's in it?
It usually contains basic data, like their email address, their first name, and their last name.
And this is where the compliance nightmare begins, doesn't it?
Oh, absolutely.
Because if a developer or a business user has been working across, say, 50 different sub-accounts over the course of 3 years, BTP has silently spawned 50 separate shadow users, 50 separate persistencies of their personal data.
Yep.
If they resign and HR deletes them from the central Microsoft Entra ID system, they can no longer log in.
True.
But those 50 shadow users, they still exist.
Yes, they do. They are entirely orphaned. And this exposes the massive flaw in what SAP calls the federation approach for user assignment.
Okay, let's talk about the federation approach.
In the federation approach, you don't explicitly provision users. You just set up rules that say, hey, when a user logs in, read the SAML or OIDC token. If they belong to the finance group, grant them the finance role collection.
Which sounds great on paper.
Yeah.
I mean, it's zero-touch administration. The user logs in, the shadow user is generated on the fly, the role is assigned, and they're working in seconds.
And it is incredibly efficient for onboarding, but it is catastrophic for offboarding.
Because there's no reverse process.
Exactly. Because the shadow user was generated organically upon login, there is no mechanism to tell the BTP sub-account when the central identity has been deleted. You are left with a permanent manual obligation.
Wow.
To stay GDPR compliant, your administrators would have to routinely write custom scripts to audit and delete inactive shadow users across every single sub-account you own.
That is completely unacceptable at an enterprise scale. You can't just be running cleanup scripts every Friday hoping you caught everything.
No, you can't.
So how do we solve this? How do we get the efficiency of automated role assignment without the massive GDPR violations?
This is where we abandon the federation approach and adopt the provisioning approach.
Provisioning approach, okay.
Remember the identity provisioning service we discussed a few minutes ago? The SCM engine.
Yes, the system that pushes and pulls identity data via APIs.
Exactly. In a provisioning architecture, you do not let BTP organically spawn shadow users when someone logs in. Instead, you connect your central identity provider to the identity provisioning service. You configure it to periodically read the central database and actively push the user records down into the specific BTP sub-accounts using SCM APIs.
So you are explicitly creating the shadow users ahead of time, basically.
Correct. And more importantly, because the identity provisioning service maintains a stateful connection to those records, when a user is deleted from the central HR system, the next time the provisioning job runs, it actively sends a delete request via a SCM to every single sub-account.
So the shadow user is wiped out automatically.
Yes. You maintain full lifecycle control and total GDPR compliance.
That is a massive architectural takeaway. So if you are listening to this right now and mapping out your deployment, you have to verify how your system is handling this right now. That's a huge action item.
Do it today.
Literally today. If you log into your SAP BTP cockpit, navigate to a hub account, click on security, and then users, you can see the list. By default, the feature that automatically generates shadow users is actually switched on for custom identity providers.
It's keep.
It's sneaky.
It is. You need to actively architect your provisioning flow to manage that data responsibly.
And knowing how to manage the lifecycle of these users is really just step one. Step two is figuring out how to actually bundle the permissions they need so they can do their jobs.
Right.
We need to transition from the identity layer to the authorization layer.
Let's talk about account-level assignment strategies then. Because if provisioning gets the user into the system, how do we assign what they can actually do?
Right.
We briefly touched on the idea that manually clicking through menus is impossible at scale. We need to look at how permissions are structured, which revolves entirely around the concept of role collections. Let's break down the anatomy of a role collection for the listener.
Okay, to understand a role collection, you have to start at the bottom.
The foundational level.
Yes. When you subscribe to a service in BTP, say the SAP Build Work Zone service, that application provides predefined granular roles, things like workspace administrator or end user.
These roles are immutable. The application developer defined them, and the BTP administrator cannot alter their specific code-level permissions.
So they are the individual keys. You can't file them down to change what they open.
Exactly. But an administrator doesn't want to assign 50 individual keys to a new hire. So the administrator creates a role collection, which acts as a keychain.
A keychain, nice.
Yeah, you take the workspace administrator role, bundle it with maybe a destination administrator role from another service, name the collection Intranet Admins, and you assign that single collection to the user.
Okay, but here is a massive point of friction I see constantly in the field. An architect spends like 3 days perfectly crafting these complex role collections in their development sub-account.
Oh, I know where this is going.
Right. They spin out their production sub-account and they assume they can just copy-paste the role collections over, but they can't, right?
No, they cannot, and this is a fundamental law of BTP. Authorizations are strictly bound to their specific account context, meaning a role collection created in sub-account A does not exist in sub-account B. It does not exist at the global account level either. Scope is everything.
So if I have 5 sub-accounts, I have to recreate that exact same role collection 5 separate times.
Manually, yes.
That sounds awful.
It is, which is why enterprise teams utilize infrastructure as code tools like the BTP Terraform provider to programmatically deploy and sync role collections across environments.
Oh, okay. That makes sense.
But the core concept remains. The authorization exists only within the physical boundary of that specific sub-account.
So we have our role collections configured locally in the sub-account. Now we need to map our users to them.
Right.
If we are using the provisioning approach via ESCM that we just talked about, how does that mapping actually occur? Do I still have to manually link the provisioned user to the role collection?
No, because that defeats the whole purpose of automation.
True.
When you configure identity provisioning, you don't just push the user record, you also push their group memberships. Yeah, so say you have a Microsoft Entra ID group called BTP Global Auditors. SIM pushes that group into the BTP sub-account as well. In the BTP cockpit, you simply map the incoming group, BTP Global Auditors, directly to your local auditor role collection.
So the logic is entirely decoupled. HR adds someone to the Entra ID group, SIM pushes the update, the sub-account sees the new group member, and the role collection is instantly applied.
Exactly. It creates a seamless, zero-touch authorization pipeline that is fully lifecycle managed.
Which brings up a very practical piece of advice, a real action item for the listener. If you are setting this up, you should immediately create a custom role collection explicitly for auditors.
Yes, highly recommended.
Just group all the basic, predefined read-only roles from your active services into one collection. When compliance comes knocking, and they will, you do not want to be scrambling to figure out how to give them read-only access without accidentally giving them the ability to deploy code.
That happens more often than you'd think.
It really does.
Yeah.
So have the auditor role collection pre-built and mapped to an empty group in your corporate IDP, just ready to be populated.
That is an excellent architectural habit to get into.
Okay, so up to this point, we have secured the global account and the sub-accounts. We've established the perimeter, we've solved the shadow user problem using SKIM provisioning, and we've mapped our role collection.
We've locked down the platform.
We have secured the platform itself. But BTP is fundamentally a platform for building things, right?
That's the whole point.
When a developer steps inside a sub-account to actually write and deploy an application, they enter a runtime environment. And the moment you cross that boundary, everything we just talked about completely changes.
It changes drastically. The platform administration layer relies on BTP role collections, but the runtimes have their own deeply embedded authorization models.
Let's start with the most ubiquitous runtime on SAP BTP Cloud Foundry.
Let's do it.
Cloud Foundry is this massive multi-tenant cloud application platform. It sits inside a BTP sub-account, but it has its own distinct hierarchy. Break that down for us.
When you enable Cloud Foundry in a BTP sub-account, you are essentially instantiating a Cloud Foundry organization, or an org. This org is the top-level management entity for that specific Cloud Foundry environment.
But developers don't actually build apps directly in the org, right?
Correct. Inside the org, you carve out spaces.
Spaces.
Spaces are the actual development environments. You might have a space for the front-end team, a space for the back-end API team, or spaces separated by project lifecycle like, dev, test, and prod.
And here's where the paradigm shifts. We are no longer using BTP role collections. Cloud Foundry ignores them.
completely ignores them. For platform users operating within Cloud Foundry, you must assign them to predefined Cloud Foundry roles.
And you can't customize them like role collections.
No, unlike BTP role collections, you cannot customize these. The roles are rigid, and they apply strictly at either the org level or the space level.
Let's actually list the specific roles, because knowing these is critical for anyone listening.
Yeah.
For the org level, you have org manager, who can manage users, and quotas org's auditor, which is read-only access, and org user.
Yep.
For the space level, you have space manager, space developer, who actually pushes code and binds services space supporter, usually for troubleshooting without full dev rights, and space auditor.
And there is a fascinating mechanical quirk in how these levels interact.
Oh, the org user quirk.
Yes. If an administrator goes into the BTP cockpit or uses the Cloud Foundry CLI and assigns a developer the space developer role in the backend space, the system automatically intervenes.
What does it do?
It takes that user and silently adds them to the parent Cloud Foundry org with the org user role.
Why does it do that? That seems redundant.
Because the authorization model is strictly hierarchical. You cannot exist in a space if you do not exist in the org. The org user role is essentially a read-only pass that allows the developer to actually see that the org exists so they can route their CLI commands through it down to the space.
Okay, but here is where I see people get incredibly confused, and where we really need to connect this back to our concept of scope.
Let's hear it.
If I am an administrator and I make an engineer a space developer, they now have a tremendous amount of power. They can deploy applications, they can bind HN databases, they can route web traffic.
They own that space, yeah.
But if that exact same highly privileged space developer clicks out of the Cloud Foundry menu in the BTP cockpit and tries to click on entitlements to see how much memory the subaccount has left, they get a massive red access denied error. Why?
Because Cloud Foundry role assignments are completely invisible at the standard BTP subaccount level.
Totally invisible.
Remember, Cloud Foundry is a runtime running inside the subaccount. Earning your stripes in Cloud Foundry does not grant you a single permission in the host's subaccount.
It's like giving someone the master key to a massive filing cabinet on the 4th floor, but completely forgetting to give them the security badge to get into the building's lobby.
Exactly.
If they magically teleport to the cabinet, they can do whatever they want, but they can't even get past the front desk of the subaccount.
That is the perfect analogy. The runtime scope is completely isolated from the platform scope. If that developer needs to view the subaccount entitlements, or, say, manage BTP-level trust configurations, you must also navigate back to the BTP subaccount security menu and assign them a specific BTP role collection, like subaccount viewer.
So you're managing two entirely distinct layers of authorization simultaneously.
You have to.
If you want to deeply understand this boundary, you have to feel it mechanically. Here is a hands-on action item. If you have a test environment, go into the BTP cockpit, navigate into your subaccount, click on Cloud Foundry, and go to org members. Add a test user.
Good exercise.
Then drill into a space and assign them space developer. Now open up a terminal and use the CF login command to authenticate as that test user. You will be able to push a Node.js app without an issue. But log into the BTP cockpit UI as that same user and watch how much of the screen is grayed out. That friction is the architecture doing its job.
That isolation is totally by design. And, Cloud Foundry is actually deeply integrated into BTP compared to our next runtime environment.
Kyma.
Yes. What happens when we move away from Cloud Foundry and look at Kyma?
Kyma is fascinating because it feels like a completely different universe.
Mm-hmm.
Kyma is essentially SAP's fully managed, enterprise-ready Kubernetes runtime.
Right.
It allows you to build highly scalable containerized microservices.
Right.
But because it is built on open source Kubernetes, does the whole BCP authorization model just get thrown out the window?
Entirely. Thrown out the window.
Wow.
When you step into Kyma, you step into pure Kubernetes. Kyma does not care about your BTP role collections. It does not care about Cloud Foundry space developers.
Okay, so what does it care about?
Kyma utilizes standard Kubernetes role-based access control, or RBAC.
Okay, let's unpack Kubernetes RBAC for the listener because it operates on a fundamentally different logic. We are dealing with role bindings, cluster roles, and cluster role bindings. How do these pieces fit together?
Let's start with the base definition. In Kubernetes, a role is a set of rules that define what actions or verbs like get, watch, list, create can be performed on specific resources like pods or services.
Okay.
But a role is strictly bound to a specific Kubernetes namespace. It is locally scoped.
So a role says something like, someone is allowed to delete pods in the front-end namespace.
Correct. But the role itself doesn't say who can do it.
Oh.
That is where the role binding comes in. A role binding is the glue. It takes a user or user group and binds them to that specific role.
Okay, but what if I'm the platform administrator? I mean, I don't want to create a role for every single namespace. I need access to the entire cluster.
Then you escalate to a cluster role. A cluster role defines permissions across the entire Kyma cluster, completely ignoring namespace boundaries, and you attach users to it using a cluster role binding.
And because this is standard Kubernetes, you cannot manage this in the BTP cockpit, right? If you try to find a menu in BTP to assign a cluster role, you will be searching forever.
Right, you won't find it. You manage this either via the dedicated Kyma dashboard UI or natively through the command line using kubectl and deploying YAML configuration files.
This brings up a really critical contradiction that I noticed in the architecture documentation.
Oh.
Earlier, we spent a lot of time tearing down the federation approach, the idea of mapping users dynamically upon login, because it creates those orphan shadow users in the BTP subaccount that violate GDPR.
Right, the shadow user nightmare.
But the SAP documentation explicitly recommends using the federation approach for Kyma platform users. Why is a practice that is considered toxic in BTP suddenly recommended in Kyma?
It's a great question, and it's because of how Kubernetes handles identity natively.
That's all.
Unlike a BTP subaccount, a Kubernetes cluster does not have a local persistent database of user profiles.
Wait, really?
No persistent user database. When a user attempts to run a kubectl command, the Kyma API server intercepts the OIDC token issued by your identity authentication service. It reads the token, extracts the group claims like, say, Kyma admins, evaluates it against the cluster role bindings in memory, executes the command, and then immediately forgets the user exists.
Wait, it doesn't write a local shadow user to the database?
No. The authentication and authorization evaluation is entirely ephemeral. Because there is no persistent profile stored inside the Kyma cluster, there is no leftover data when the user leaves the company.
That is amazing.
Therefore, utilizing federation, dynamically mapping your corporate Untra ID groups to Kyma cluster roles via the OIDC token is perfectly safe, highly efficient, and 100% GDPR compliant.
That is an incredible architectural nuance. The exact same concept, federation, is a compliance nightmare in one runtime and best practice in another, entirely due to how the underlying database handles persistence.
It's all about the database.
But wait, let's clarify a massive point of confusion. We've been talking about the builders of Kyma, the platform engineers using kubectl. What about the business users?
Good distinction.
What if I deploy a standard SaaS application onto my Kyma cluster and an HR manager needs to log into it? Do they need a Kubernetes role binding?
No. And this really highlights the split personality of SAP BTP. When you build a business application on Kyma, you protect its endpoints using the XSUAA service or the AMS service we discussed earlier.
So the application itself reaches out of the Kyma cluster and talks to the central BTP security services.
Exactly. The business user authenticates through the standard identity authentication flow, and they receive their authorizations based on the standard BTP role collections you configured in the BTP cockpit.
So they don't touch Kubernetes at all?
The business user is completely oblivious to the fact that the application is running on Kubernetes.
That is the ultimate test of understanding scope. If you are building the engine, if you are the Kyma platform admin, you speak Kubernetes RBAC and you manage it in the Kyma dashboard. If you are just driving the car, if you are the business user, you speak SAP BTP role collections and your admin manages you in the BTP cockpit.
Precisely. You have to know exactly which persona you are serving and which plane of the architecture you're operating on.
So if you are an architect, here's your action item for Kyma. The best way to internalize this is to log into the Kyma dashboard, not the BTP cockpit, and physically write a YAML file that creates a cluster role binding.
Get your hands dirty.
Exactly. Bind a custom group from your OIDC token to a deployment role and execute a command. Prove to yourself that the authorization engine is running entirely within Kubernetes, completely decoupled from BTP.
All right, so we've navigated the tight integration of Cloud Foundry and the open source decoupled nature of Kyma.
What's next?
We have one major runtime left to dissect, and it flips the script yet again.
The ABAP environment.
Yes, ABA.
For decades, ABAP has been the proprietary programming language in runtime environment, driving SAP's massive ERP systems. Now, it exists as a modern cloud-native runtime within BTP, but it definitely carries its legacy with it.
It really does. And because of that legacy, the fundamental rules we've established for BTP do not apply here.
Seriously.
Seriously. Specifically, the strict separation between platform users and business users, which, as we discussed, is the bedrock of BTP security, simply doesn't exist in the ABAP environment in the same way.
The documentation is explicitly clear on this. I was reading it, and it says there's no separation between platform and business users.
Right.
Instead, the ABAP environment relies on three entirely different personas.
Yeah.
Business users, technical users, and communication users. Let's break those down, starting with why a developer is suddenly called a business user.
Well, in the ABAP paradigm, a business user is defined simply as a real human being operating via a web browser or a development tool.
Okay, a human.
Right. Whether that human is an ABAP developer writing backend logic, an administrator configuring system parameters, or an end user running a financial report, they all authenticate and log in as business users.
Okay, so if humans are business users, what is a technical user?
A technical user is non-human. It is an internal background identity used by the system to execute local or remote processes.
Like automated jobs.
Exactly. These are essential for cloud management activities, like the automated jobs that provision the system or run database cleanups. Humans never log in as technical users.
And then there's the communication user. How does that differ from a technical user?
A communication user is a highly specialized subset of a non-human user. It is explicitly designed for inbound system-to-system integration.
Okay, give me an example.
For example, if you have an external analytics platform that needs to securely call an API exposed by your ABAP environment to extract data, that external system authenticates as a communication user.
And because it's a machine-to-machine interaction, they obviously aren't typing in a password on a login screen.
No, definitely not.
They're using basic authentication with extremely complex rotated passwords, or probably more securely, authenticating via mutual TLS using XML 509 certificates.
Exactly. The communication user is strictly bound to specific communication arrangements that govern exactly which APIs it can trigger.
But let's go back to the human element, because this is where the friction is for me.
Yeah.
If the lead ABAP developer and the entry-level data entry clerk are both categorized as business users, how on earth do we differentiate their access?
Right. It sounds confusing.
Because if we aren't using BTP role collections, what is the mechanism?
We use an identity access management model that is functionally identical to SAP S/4HANA Cloud.
Oh, wow.
Yeah, the ABAP environment brings the ERP security model into BTP. It revolves entirely around two core concepts: business catalogs and business roles.
I love the mechanics of this model. Let's dissect a business catalog. A business catalog is the absolute smallest, most granular unit of functionality, right?
Yes.
It might grant access to view a single Fiori application or even just to activate a specific button within that application.
Very granular.
But here is the critical constraint.
Yeah.
As a customer administrator, you cannot create or alter a business catalog.
Right. Business catalogs are predefined and maintained entirely by SAP for standard apps or by your ABAP developers for custom apps. They are immutable blocks of code-level authorization.
But you can group them. And this is where the administrator takes control. You take multiple business catalogs, say a catalog for viewing purchase orders and a catalog for approving them, and you bundle them together to create a business role.
Exactly.
You then assign that business role to your business users.
It's a really elegant system because it enforces a strict separation of duties. The developer defines what the application is capable of doing, that's the catalog. But the security administrator decides who is allowed to do it, the role.
I like to think of it like a high-end restaurant.
Okay, I'm listening.
The business catalogs are the individual ingredients: the flour, the tomatoes, the basil. SAP provides these ingredients, and you cannot alter their molecular structure.
Right.
But the business role is the recipe. The security administrator has total control over the recipe. You decide exactly which ingredients to combine to make a specific dish, and that dish is what you serve to the business user.
That analogy perfectly captures the flexibility of the model, but it is really crucial for architects to realize that this entire ABAP IAM system is completely insulated from the BTP account roles we discussed earlier.
And this is where the architecture gets incredibly meta. Because physically, the ABAP environment actually runs on top of the Cloud Foundry runtime, right?
Yes, it is a service provision within a Cloud Foundry space. And this layered architecture severely tests an administrator's understanding of scope.
Let's walk through a scenario to prove that.
Sure.
To physically create the ABAP environment, to tell BTP to spin up the ABAP database and start the ABAP server, An administrator needs specific BTP permissions and Cloud Foundry permissions, like space developer.
Right, they need the infrastructure permissions.
But once that server is running and the environment is active, what do those Cloud Foundry permissions mean inside the ABAP environment?
Absolutely nothing. Zero.
Wait, really? The person who built the environment has no power inside it?
None. Being a space developer allows you to manage the infrastructure hosting the ABAP environment. But the moment you try to log into the ABAP system itself to create a database table or write a line of code, the system doesn't check your Cloud Foundry roles.
It checks your ABAP business roles.
Yes. If you haven't been assigned an ABAP business role containing the correct business catalogs, you are locked out of the very system you just provisioned.
So you need Cloud Foundry roles to build the physical building, but you need ABAP business roles to actually unlock the doors inside the building.
Exactly. And to manage those ABAP roles, you do not use the BTP cockpit. You log into a dedicated web interface, the SAP Fiori Launchpad, specific to that ABAP environment.
The Fiori Launchpad.
Yeah. You open a specific app called Maintain Business Roles, and you manage the authorizations entirely within the S/4HANA paradigm.
So if you're listening and you are transitioning from traditional SAP administration into BTP, you need to physically experience this separation. This is your action item for ABP.
Try it out.
The next time you are in your environment, bypass the BTP cockpit entirely. Open the SAP Fiori Launchpad for your ABEP environment. Find the Maintain Business Roles app. Don't build a role from scratch. SAP actually provides business role templates. Base a new role on a template, customize the ID, review the specific catalogs it contains, and assign it to a test user. Feel how different the S/4HANA authorization model is from standard BTP role collections.
We have covered an immense amount of ground today, traversing multiple complex architectural paradigms.
Oh, I really have. Let's synthesize this. If there's one overarching critical theme to mastering SAP BTP authorization, it is that security is an exercise in understanding scope.
Absolutely. An authorization is completely meaningless without a specific context. BTP account-level role collections control the platform infrastructure. Cloud Foundry spaces isolate the developers using rigid org and space roles. Kyma utilizes ephemeral Kubernetes RBAC to secure the cluster. And the ABAP environment relies on its own S/4HANA-style business catalogs and business roles. You must fundamentally know which scope you are operating in before you attempt to assign a single permission.
We promised you a highly structured, actionable breakdown today, bypassing the fluff. So let's review the architectural mandates you need to execute. The checklist.
Number 1.
1. Abandon the default SAP ID service. Claim your custom identity authentication tenants immediately to ensure you own the lifecycle of your users.
Number 2.
2. Establish exactly one custom OIDC trust per sub-account to prevent token fracturing and enable centralized AMS policies.
Number 3.
3. Stop the organic proliferation of GDPR-violating shadow users. Implement the provisioning approach via SCIM to tightly couple your BTP access to your HR system's source of truth.
And number 4.
4. Respect the runtime boundaries. Execute your role assignments natively, whether that is in the BTP cockpit, using kubectl for Kyma, or navigating the Fiori Launchpad for ABAP.
If you master those concepts and actually execute those steps, you are not just checking security boxes. You are building a genuinely secure, scalable, enterprise-grade architecture.
But before we let you go, we want to leave you with a final provocative thought. Something to deeply analyze as you design these systems. We've spent this entire deep dive deconstructing static roles.
Right.
You create a role collection or a Kubernetes cluster role binding, you assign it to a user, and it just sits there, persistently granting access until someone manually revokes it, or a CM script runs.
It's a highly deterministic, rigid model based on a single snapshot of trust.
But as enterprises rapidly accelerate toward fully autonomous AI-driven operations, will these static administrative assignments become completely obsolete?
It's a fascinating question.
Yeah, imagine a near-future architecture where SAP BTP dynamically generates, grants, and revokes scopes in real time at the millisecond level. An authorization decision, not based on the static fact that you belong to the finance group, but based dynamically on behavioral biometrics, your immediate contextual risk profile, the specific device you are holding, and the exact API endpoint you're trying to hit.
It is zero trust taken to its absolute AI-driven logical conclusion. It really forces us to ask, are we currently optimizing IAM architectures for an era where the fundamental concept of a static role is about to cease to exist?
It's a massive paradigm shift to consider. Are we spending thousands of hours building highly sophisticated, multi-layered padlocks in an age that is on the verge of inventing the biometric force field? Keep that in mind the next time you find yourself manually mapping a space developer role. Thank you for joining us on this deep dive into SAP BTP Identity and Access Management.